On the bench today we have a realistic Navaho. This is a model TRC-457. So this is a 40 channel, well, we'll get to that, but it's a AM sideband radio. This belongs to an amateur radio operator, which honestly probably half of the CBs, if not more, that I work on actually belong to amateur radio operators. In actually talking to this guy, we kind of agree with that. Yeah, a lot of amateurs, they'll never admit they talk on a CB, and when they're talking on a CB, they'll never admit they're a ham radio operator. But yeah, it's surprising how many amateurs actually do still talk on CB, because honestly, this is a great way to get into radio, CB radio. You can pick up a used CB radio, cheap, slap a little small antenna up, you're on air. You can, if you've never used a radio before, it's a great way, if you're nervous or hesitant about using radios, CB is a great learning platform. You can talk on a CB for a while, while you're studying up to get your amateur license. But this is a radio from his early days. So he has had this thing for, I guess, a few decades, and it was modified by him a long, long time ago. And it's apparently sat in storage for a very long time. And he got it dug back out, and he just wants to get it back up and running, again. Basically just leave all the modifications that are there. It does look like the AMC, I'm not sure, I haven't really completely looked over it really good yet, but it looks like the modulation limiting circuit may have been disabled. No choice, I work on a radio, that's going to get re-enabled, so. But anything else that he's done to it, so he has a low power mod on this, not a high power mod, a low power mod, and the switch in one position puts it just normal 4 watts, and then when you flip the switch the other direction, it's down to, I think it was like 3/4 of a watt. So, kind of like a little QRP rig, but it does work. So, I powered it up DC first, just really quick, wanted to test it. Then I, hooked it up to an AC line, and you can see it's working. The clock is working, and yes, that's real time. That's not that fake time that everybody else uses. They're using time on this like the way I like to tell time, military time. But so the modifications that have been done to this, like I say, it has a high-low power switch, and it has basically every channel modification, I guess you could say switch position, that's possible. So this uses a UPD 858 chassis, probably one of the best chassis that Uniden ever produced. I prefer them over the later version chassis like are used in Cobra 148s and 2000 GTLs and honestly dozens of other radios. This chassis was used in countless radios, but of those two styles of chassis, I prefer these better. These have, in my opinion, just better receivers. And actually, the transmit audio sounds better on these. They had a really good microphone amplifier circuit on this chassis. But, so it looks like with some just looking at it, channel mods, like I say, it's probably had pretty much every switch position that can possibly, every combination for programming the BCD inputs on the PLL have been done. It looks like, I think it's the ANL switch is a part of the channel modification, and then there's a little box. It actually mounts up here on the top of the radio. Now, when he did this, he didn't punch any extra holes. Great for him. I hate holes. Holes that aren't supposed to be there. So what he did was, you can see there's a bird nest of wires come in through the back, the rear plate on the back of the radio there, and then he had this little plastic project box. They've been making these things for decades. Though I can't say I've seen a blue one in a really long time. Nowadays they're just all black. But he had this mounted right here, and what he did was just drilled a single hole through it right there, and it was just, he used an existing hole. There's 2 screws that hold the top cover on here and here, and he just used one of those existing holes. Great. No extra holes, because like I say, we hate holes. So all of these switches look to be channel modifications in addition to, like I say, I think it looks like I think it was the ANL I'd figured out was also channel modification. And then this switch on the side is his high, or actually not high, low. It's normal power or extremely low power. Now internally I'm going to have some cleaning up to do. I'm not sure, something was spilled in this thing from the looks of it. I mean, it's a little dusty and dirty, don't get me wrong. Yeah, it's expected with a radio of this age. But something has happened in this entire area here. Yeah, let me grab a pointy stick. Get my big fingers out of the way. If you look at all these trimmer resistors, you see, depending on the way the light is, but you can see there's green on a lot of these. One down there, the bias controls. That green is not paint. That green is oxidation or corrosion. The leads of almost every terminal and everything from like here, spreading out through here, it's kind of like something maybe got spilled. Actually, where's the top cover? Look at it. Yes, it does have, I couldn't remember off the top of my head. Yes, it does have a bunch of vent holes. The whole top is perforated. So something was spilled down through here at some point. But you can see, if I get the camera down a little bit closer, you can see, doesn't show up very well on camera, but you can see there's some green on all of these leads. I don't know if this one capacitor here was cut. Kind of looks like it, but that lead is not even attached. If I can get down in here, trying to work around a camera, if you can see, I can move that lead. It's not attached to anything. It's off of that capacitor. It's supposed to be, the other end's supposed to go to that, and it's all green too. But I think that may have been cut. I'm going to have to look at it. The reason I'm not sure is this does not have an original driver and final transistor. These are RCA transistors in here, and this would not, from the factory, have had RCA transistors. If I can get the light right in there, you can see it. You can see the SK number, which eventually was turned into, ECG NTE nowadays. But yeah, SK, what is it, 3197 and 30. I can actually see it better through the viewfinder than looking at it. 3239 for the final, I think. Can't really see down in there. That little coil, little brown guy right there is in the way. But yeah, so it's had those replaced at some point in time. But yeah, actually with this camera angle, you can see even better. You can see the green there. It's just absolutely everything in this entire area. It's green. The bottom, the leads there. So yeah, I'm not sure what happened here. It's not really bad in there. You can actually see all of these leads. You can see better now. The camera's at this angle. You can see how green everything is. Like I said, I don't know if maybe something got spilled down through here. But the radio works. And the corrosion's not really bad. So what I'm going to do is I'll just stand the radio up on its edge. He wants the electrolytic capacitors replaced. I'm going to be cleaning the bottom side of the board off with isopropyl alcohol. What I'll probably do is use isopropyl to clean this, try and basically sanitize this whole section of the radio right here. Because it does look oily. You can see there's like a stain on the board. Everywhere where there's corrosion, you can see there's some kind of residue left. I don't know if you can see it. I'm making a shiny spot there on the board because I'm rubbing some of it off. But yeah, whatever it is not highly corrosive. But yeah, it's caused some oxidation, all the trimmers. So I'll like I say, just clean the whole area with isopropyl, and it doesn't spread anywhere else. There's everything looks fine out here. Looks like it didn't get back to the relay. There's a little bit right there. So yeah, it was just basically confined to basically the RF amplifier section. That's pretty much the only thing it hit, and a few of the little controls over here. But yeah, it was mainly the RF section here. So you can see there's obviously a trimmer potentiometer up here. It's no longer mounted down on the board. That should be, I believe that's his high and low power. Trace the wires over. Yeah, that's just his high-low power, because that is your carrier adjustment down there. So yeah, he just, I guess, took that up off the board and actually used that's actually a lot better quality trimmer. Yeah, I'll try and insulate that because I don't want that coming down. Not that this thing's getting launched into space, but those are all exposed leads, and the strap for this transformer here that wraps around the core, that of course is down to DC ground, so you know it has a potential of shorting out. So yeah, I'll make sure that gets wrapped up. But otherwise, like I say, it looks fairly good. It does have the normal brown corrosive glue. Well, it didn't start out brown, it was actually kind of tan, but you know, this glue, it's all over the place in the radio, so I'll need to get the glue cleaned off. You know, that cap will get replaced anyhow. But yeah, other than that, you know, 2 diodes lifted up here, that one and that one. Like this is your audio circuit, so you know, like I say, the limiter circuits looks like they've been disabled. I don't let anything like that go, because all that does is it doesn't do you any good. I've shown that time and again. All you do is you actually lose audio power on channel, and you end up creating a lot of extra power, you know, because you'll see it on your watt meter. Oh man, the needle's really swinging good now, but the problem is all that newfound power, of course, is in the adjacent channels or in harmonics. So, you know, if you want to talk on television, or if you want to talk to the guy on the channel beside the channel you're actually on, yeah, these modifications are great, but otherwise, you know, those circuits are in there for a reason. You know, keep them installed, set your modulation and, you know, to 100%, set your ALC so it's, you know, not distorted, and just leave it alone, and your radio will sound better and transmit farther than if you do these modifications. Because like I say, all your newfound power goes elsewhere. It's not on channel. It's not actually doing you any good, and it's hard on the radio. And actually, you know, stuff like that causes you know, no saying why the driver and final transistor were replaced in this, but you know, these things are making a heck of a lot more power when you go doing crazy modifications to radios. And where a stock radio with an intact limiter circuits and whatnot will hum along for decades just fine, you go doing a bunch of crazy power modifications, you start burning out parts like this, voltage regulators, driver, final transistors. Just, you can have a plethora of problems. Just use the radio the way it's designed, at the power levels it's designed to be used at, and it'll last probably the rest of your life. You know, that's basically the way to look at it. So yeah, other than that, it needs a cleanup. Like I say, you can see the dust monsters have definitely been in here. Yeah, there's a few colonies of dust bunnies, but just a dusting with a paintbrush and a vacuum cleaner will clean all that up. So yeah, just dusting, a little bit of cleaning off of the board here. I think that'll probably be fine. I just need to remove whatever that goop is there, try and clean it up really good. A little bit of deoxide on these trimmer resistors. As long as they're fine, it hasn't damaged the actual carbon trace that runs, you know, from this terminal around to the other terminal. As long as the carbon tracks are still fine and they clean up fine, I'm not going to replace them. Yes, I know some people are, but the corrosion started, you should, yeah, honestly, yes. Everything in this entire area, if you really wanted to do this right, honestly, absolutely every component from basically this transformer can to here and over, everything should be removed off of the board and pretty much replaced, because it's corroded, you know. But how far do you want to go? It's still working. Like I say, it looks like just slight surface oxidation. It's not crunchy and chunks of corrosion falling off. So I'm probably just going to do a good cleanup. I think that should probably suffice. And of course then we have all the, this will all just get left in, because he said just leave the channel mods. You know, so all he did here was just ran the wires in, basically tinned the, because it was stranded wire, tinned them so they were basically solid, and then just pushed them down in the backside of this flat flex cable. That's what this is, flat flex cable. You know, goes in here, but there's enough room between the back piece of plastic of that housing and the backside of that terminal where you can actually shove the wires down in, so he didn't even have to solder them on. I mean, talk about, if you at some point in time wanted to remove the modifications, talk about easy. Pop the top cover off and just pull the wires out. It doesn't get much easier than that. And yes, the clarifier is unlocked. You'll see there's a little purple wire there, so it's picking up the voltage to volt the clarifier there. The controls are dirty as all get out, because I did have this hooked up to the spectrum analyzer, and you know, when I turned the clarifier, you could see the frequency would jump up and down and jiggle, and as you're turning the clarifier, it's just because it's dirty like the rest of the radio. So yeah, it looked like basically just a recap. Clean this goop off the board over here, general cleanup, and should be good to go. Like I say, it's a little bit of maintenance. You know, I'm not sure what happened here. He accidentally maybe touched this with a soldering iron, because the insulation's all melted right here. But the back side of the wire's fine, so it's not like it overheated. I think it's just a soldering iron, maybe when he was, because he actually did have to pull this pin from the PLL up and then solder a wire to it. So I don't know if maybe, you know, came in at this angle with a soldering iron and accidentally melted that. But I'll pop that off and put a little piece of heat, because I can actually see the wire in a few spots there. So I'll put a piece of heat shrink tubing on that. But yeah, otherwise looks pretty good. You know, he knew what he was doing when he did this. You know, a few things, yeah, questionable the way they were done. I mean, you got to realize he did this a long time ago. I'm sure this was kind of a learning platform for him. But you know, black tape, the black tape will be going away. Whatever's, which actually, you need to just pull that off. Is that another melted wire? No, it's just, it was cut and soldered back together for some reason. So yeah, I'll just desolder that, put a piece of heat, again, put a piece of heat shrink tubing on there. Don't like black tape, and I just tossed it back into the radio. I don't, darn it, get out of there, little guy. Just don't want to stay in my hand. I don't like black tape because eventually like this one, you know, it's not sticky anymore. It just dries, the adhesive eventually dries out. So it's always best to put a piece of heat shrink tubing. Same thing here. I'll just desolder this wire off of this diode, slide a little piece of heat shrink tubing on here, resolder it back on, and slide the heat shrink tubing down over it. But that prevents anything from ever, you know, if the radio takes a really hard bump and, you know, stuff's moving around in here, you don't ever have to worry about anything shorting out. But there you go. So there's a before. That's basically what I wanted to show. And let me get to work here doing some cleaning and parts changing, and we should be back with a good working radio that, of course, has all of these limiters installed, and see what she looks like. Okay, so I'm actually had got done doing the just a dust brush and vacuum cleaner. Cleaned this area with isopropyl alcohol, and honestly, all the green stuff just pretty much rinsed off. It was just very, very light surface oxidation. I mean, I don't think I've ever seen corrosion that light before. So yeah, it really hadn't done any real damage. It does look like that ceramic capacitor there was probably cut. Or accidentally damaged. I need to check that. But like I say, when you use aftermarket driver and finals, I might have forgot to mention that before. A lot of that's why I never use aftermarket driver and final transistors, you know, RF transistors. Pretty much anything else in a radio fails. You know, voltage regulators, small signal transistors, switching transistors, most all of those, they're usually fine if you use an aftermarket substitute. A lot of times the substitutes you'll use, you know, like RCA back in the day when they had a line of substitute semiconductors. A lot of times their specifications are actually better than what you're replacing it with. But there's one exception I have found, and that's driver and final or just RF transistors in general. So like a pre-driver, a driver, and a final transistor, if one of those goes bad, the only thing I will use to replace it is a like component. You know, the same thing, basically the original, a factory original. Because using a lot of times when you use substitute transistors in these applications, you're going to find your power's low, you've got weird oscillation problems, especially if it's a sideband radio. You can just end up with a lot of weird problems, and it's all caused because it's a substitute. It is not a direct match. Most of these manufacturers, when they come out with these substitute transistors, you look at the replacement sheet for it, and it'll replace like 30 or 40 different transistors. You know, the 1306, 1307s, 2166s, 1969s, and 3 dozen other ones that they'll replace for driver and final. I'm here to tell you people, those transistors all have different specifications. You can't easily just put one of those in place of one of the others, so it's not like there's some magical, you know, had fairy dust sprinkled on it transistor you can put in there that just works in all applications. Like I say, most general applications, they're usually fine. You don't have a problem. These applications you do. So a lot of times you'll see that. You'll see if someone has installed an aftermarket transistor, they may have had to change the bias on the transistor. So you might find resistor values have been changed. You'll see capacitors either cut out or removed out of circuit, different values put in, maybe an inductor installed. Yeah, you can have to do all kinds of modifications to try and get those to work. That's why I usually prefer to use the originals. But anyhow, what I'm doing is, you can probably see over here, I'm in the process, like I said, I got the area cleaned up, got the radio cleaned out, looks good. All that green goop pretty much just all rinsed away with some, a brush and a little bit of isopropyl alcohol, so, that's good to go there. I'm now working on the dreaded corrosive glue, and I seem to get a lot of questions. People always emailing me, and it seems to be never ending. How do I get the glue out? Honestly, people, there is no easy way. There is no magic answer to tell you how to get this corrosive glue out. It ain't easy. It's not exactly difficult. It's just time-consuming. But there's no mystery sauce you can pour onto this stuff, and you're going to just soften it up, and it's just going to fall off or dissolve without softening up and dissolving the rest of your radio is the problem. It's just kind of down to elbow grease. Now, for me, it's the easiest way, because I have desoldering irons. Now, you don't have to have a desoldering iron. You can just use, Chemwick, a desoldering braid works fine too. But yeah, I've got the desoldering tool. So the easiest way I've found is trying to get that goop off of terminal leads. Now, if it's only down around one component, you can see the whole way around the lead, and you can easily pull it off with, this is where it's going to pay to have lots of, not exactly specialty tools, but just all kinds of dental instruments of destruction and some other stuff. So yes, get yourself some old dental picks on eBay, or around here I pick up stuff like these. We have Carlisle, Pennsylvania is just right up the road from me a little bit, and I go to at least one of the main car shows a year. And there's dealers up there that sell old dental tools. You can get good. Now, these are all good, high quality, made in the USA or Switzerland ones. But you can get, honestly, the cheap Chinese ones. It's not like you're going to be doing dental work. You're working on a radio, so yeah, even if the tips break off of them eventually, what are you going to be out? Probably not much money. Get yourself a good set of tweezers. Now, you don't have to go get a big fancy kit. Maybe one or two, but buy some at least halfway decent ones. The ultra cheap Chinese ones. Now, don't get me wrong. I actually have those here. So I've got this one is Aven. Okay, it's made by. Right there, you can see it. Aven. I think they're made in Pakistan. I think. Yeah, made in Pakistan. But they're good tweezers. These are not cheap tweezers. They're not Swiss made. I've got Swiss made tweezers, but I don't use those working on radios. But these are the Aven brand ones are the ones that I use for most of the stuff when I'm working on radios. But I also have cheap ones. So I have, these are cheap. Actually, that's not the same style there. Because a lot of times you can get a set, let me set some of this stuff down, running out of hand to hold all this stuff. You can get the, like in this case, the Aven brand, and then when you get the Chinese set, pretty much the lengths may be a little bit different, but the tips are about the same and whatnot. Now, they're not as strong. The metals, as you can see, the metal's not as thick. So, these things are more easily twisted. But honestly, that's a really good way. Now, the glue in this radio's gotten to the point where it's starting to get hard. Here's actually a piece of it. It's still flexible, but it is getting hard. It's not what I call juicy glue. So, when it's still what I call juicy, it's still very, very rubbery. And it's usually extremely easy to get off when it's in that state. If you get the edge of it lifted up somewhere, you can just grab it with a pair of tweezers, hold it, and twist it. And you can literally, if this is the terminal lead, you can just unravel that stuff off of the part. Peel the sheet just basically right up off of the radio. It'll just, pull off fairly easily. Now, I found it's better to do the twisting thing than it is to try and pull. Because when you're pulling with, tweezers or even needle nose pliers, you still have sharp edges, and all you end up doing is ripping it off in little chunks that just look just like your tip, because it just breaks through the edge. If you roll it off, it wraps around here. It's a very gentle edge then, and usually it doesn't break. You'll get it all. You can a lot of times get that stuff off in one big piece. When it's in the condition that this stuff is, this has gotten to the point where it's starting to get hard. It hasn't done any damage yet because it had only in a few spots where there's a lot of heat in the radio. Down here on the clock board, that IC gets baking hot. The power supply board gets really hot, so the glue that was around this capacitor, which has actually been removed, you can see how it's dark brown. I mean, almost black. It's not that it's burned. That's just what happens as it decomposes and becomes conductive and corrosive. That's what it does. It turns from a really almost just opaque tan color to almost burnt black color. And the darker it gets, the worse that stuff is. That's why you want to get it out of your radio, because it becomes corrosive and starts to literally eat the leads off of stuff. And heat accelerates that process. But those, like I say, those are the hot spots in a radio. Now, it's all over the place anywhere there's a toroidal transformer or coil. So, like these. So they have glue. You can see it's still all on there. But this is the easiest way to do it. Just remove the parts. Trying to get this glue off of parts in these areas, you're never going to get it off. You're never going to be able to get underneath all the leads. They're all packed in around each other really tight. Just desolder those couple components. Lay them on your bench. Just in the order that they came out of the radio. It's real simple. Actually, I put these in the wrong order. That should be there. But yeah, I mean, this resistor goes in this orientation, capacitor here, the coil, and then there's a capacitor on the other side of it. Same thing here. There's a capacitor in this orientation, this one goes in this orientation, and then a transformer. So, you know, there's 2 holes there, and the 3 for the transformer. But just lay them on your bench in the order that you took them out. Now you can very easily get in. Instead of trying to work underneath of parts, you can just get in, and that's where I like this dental tool. I'm not a dentist, so I have absolutely no idea. I can't remember exactly what they call it. This one's, I think, made by Hue Friendly. Yeah, this is a Hue Friendly. I'll never get it to focus on that laser etching. But it's a Hue Friday, F-R-I-E-D-Y. Yeah, they're made in the United States. They're good, high-quality tools. But this is a, what is it, PFITR half. But it's some kind of like a spatula doohickey. It's got one that goes, you know, flat-sided that way, and the other one comes around kind of like a foot. And they're handy because actually if you're removing integrated circuits in really compact areas and you can't get an IC puller down in to pull the ICs out, these are great for removing ICs too. You desolder the IC, you can just slip this foot underneath, you know, in tight cramped spaces. You can get that foot under there and pry up the IC from either end to get it out, so it's handy for that too. But I have some of these, like this one, what I've done is taken a diamond hone and actually sharpened the tip of this thing. Now, it's not not like it's cut me sharp, but it's a lot more sharp than it was originally, because it was originally kind of blunt. It'll never focus on that, will it? Yeah, there you can see that one's kind of blunt on the tip, where this one, like I say, it's a lot thinner. You can see how thin it is there at the tip. But when you get down in here, the glue remnants that's still on the circuit board, it's real easy, and of course my mount is in the way. But what I find is I can lay this flat on the board then. I can just work this up underneath of the glue. And there, just kind of pop it off in sheets. And at the same time, I'm not damaging the circuit board and scraping off all of the silk screening for component identification down here. That's the problem if you use, you know, a pick type tool that has a sharp point like this. When you're trying to scrape all that glue off, a lot of times you end up taking all the silk screening off. Now, you're not actually damaging anything, but if at some later date you need to replace a part and you're looking on the schematic and you're trying to find C187 that's right there and it's all been scratched off, it can make it a little bit more tricky. Or you see a part that's bad. That's why the silk screening's here. It makes component identification easy. So yeah, like I said, this little flat-footed thing with a sharpened edge, or actually the other end, this end here is really handy for that. Like I say, you just slightly sharpen it. It just allows you to slide right underneath the glue and just pop this grungy stuff off. You see that? I can scrape all that stuff off of there, and absolutely no damage to any of even the silk screening. So, you know, the board's not all scratched up and looks good. Like I say, if you scratched a board, it's a fiberglass circuit board. It's not like you've damaged it. You haven't hurt its integrity. But like I say, I try to leave the silk, the circuit identification silk screening on the board. I try not to damage that too much. But that's the whole trick. Like I say, it's just a time-consuming process. you'll find you're much more effective if you remove the parts. Now, if you remove a part and the leads are extremely damaged, they're very heavily oxidized, don't be surprised. A lot of times you go to take a part off, the lead falls off. Or you're working on something, like these toroid transformers. You'll go to take these out, and you may find, if the radio didn't work, for starters, a lot of times what you'll find is, especially if you've lost transmit. Now, in this chassis, this has a death nail. There is a coffin nail in this radio that was installed at the factory, and that coffin nail is that little blue guy right there. It's a tantalum capacitor. Get the light right here. You can just see blue. I've said this every time I work on one of these radios. When you replace the electrolytic capacitors, you usually don't have to worry about tantalum capacitors. They're very durable and they hold up fine, except for one thing. If it's a UPD-858 chassis, always replace that one tantalum capacitor right there. That thing is known. I've seen that more times than I've got fingers, and probably fingers and toes. I've seen that capacitor shorted out. You won't have any transmit. You replace that, because that you can see, here's your bias lines, okay? Your final and driver bias lines. That little cap fails, yeah, it can cause all kinds of problems. You'll lose transmit power, so always change that. But anyhow, like I say, the glue, a lot of times you'll find when the transmit, you don't have transmit power, and not just this radio, any radio that uses these toroidal style transformers. The presidents are actually well known for that. The unit and president, like HR 2510 and 2600s. You see, when I do the videos on those, I always pull the transformers out, and a lot of times I have to rewind them. Now, not big ones like this; they'll be smaller. Or if, like, you're working on a Cobra 148 2000 GTL, in the orientation that this board's in, there'd be one in the back corner over there, because the driver and final in those radios is along the backside. There's a little toroidal coupling transformer right around here in those radios. Those things, those little small ones, the wires, I'm not going to say they're microscopic, but they're tiny. They're smaller than the wires that are on this. And you just touch it, and the lead will break off. So it's just a matter of rewinding the transformers. I've shown doing that, and I think some of those president videos before. It's just a matter, count your windings, the spacing, where the windings are on here, make yourself a little road map, just basically, and rewind it. But yeah, it's the easiest way. You're never going to get all the glue off of this thing, for starters, but you don't have to worry about it. The advantage here is this wire is enamel-coated wire. It's what they call magnet wire, and it's what it's meant for, winding transformers like this. Same thing they use in large transformers. So it has an enamel coating on it, and the glue, I've never seen anywhere where the glue actually damages that enamel coating. The only place you get damage is right at the ends, because what they do is they strip the enamel coating off of this, so of course it can be soldered, down to your circuit board. So now that's exposed metal, and that's where you'll get corrosion. So you really only need to remove this glue right where the wire, that enamel coating has been removed from the wire. That's really the only place. Now, if the wire breaks off, like I say, hopefully you've got some enamel wire around, because when you rewind these, you want to make sure you use the same gauge wire. So you can't just grab any old piece of wire, slap it around here, and wind yourself a new transformer and expect it to work properly. It's going to need to be the correct gauge wire. But yeah, just be careful. Parts like this, they're cheap. If there's even any sign of corrosion on a 1-cent part like this, I'll just drop a new one in. I mean, green poly-dip capacitors and ceramic capacitors like this, if there's any sign of corrosion, I'm just going to replace the blasted thing. These things they're so cheap. It's going to cost more in time for me to clean the leads off than it is for me to just turn around, pull a parts drawer out, and just slap a new one in the radio. Like I say, when you're talking parts that are literally 1 or 2 cents a piece, it's a time, how much is it going to cost in time for me to do it versus just using a new part. But, so there's a little bit more. I just thought I'd cover that a little bit more. I see I get so many questions. People ask me about removing that glue. Short answer is, there is no short answer. It's not easy. It just, whatever works best for you. Now, some of the radio, TV, cement solvents I use, they may soften it up a little bit, but the problem is some of those solvents can also damage plastic components, parts that have plastic, or you don't want to be dribbling any on faceplates of radios. a little bit of isopropyl alcohol, that doesn't really seem to do anything to this stuff. I don't want to say it's impervious goop, but short of the acetone-based radio TV cement solvent that I use, there's really nothing that gets it off. The radio TV cement solvent does. That stuff, it softens it up. You'll see it bubbling up. It just gets all goopy again. Like I say, the problem with that stuff is it's made with acetone. That's the main ingredient in radio TV cement solvent. And now in this area, like right here, that wouldn't be a problem. There's, ceramic capacitors, resistors, diodes, glass, everything's glass or metal or ceramic, or, there's nothing that's really going to melt. But, in other parts of the radio, you don't want that stuff touching wire, because that stuff will melt the insulation off the wire. Anything plastic, this tubing and whatnot. Electrolytic capacitors, it'll melt the outer tubing off of this stuff. Have to be really careful on transformers, because it will soften up the plastic on these transformer cores. You can use it sparingly if you get cores that are glued in, but just don't go using a lot of it, because like I say, it will soften up the plastic that's used on those core forms that go down in there. But yeah, usually, honestly, the best thing is dental picks and a tweezer. A scraper, same thing as, just a circuit board tool, but, with a little scraper on there, same principle, get under it and just scrape the stuff off. There is no easy answer. It's just elbow grease. That's basically what it comes down to. So let me continue on with a little bit of elbow grease, and we'll be back later with a finished up radio. Okay, so for the most part, she's pretty much done now. This has definitely been one of those radios that test your patience. I recapped the radio and all of these wires that have been added and all these modifications. Oh man, the soldering on them were just horrible. Everything you'd touch, the wires would pop off. You'd go to do something else, and another wire would fall off. You'd go to touch something else, it would break off. Yeah, just so many cold solder joints. So, I still got it on with the squelch up there. So I had taken all of this out here, cleaned off the corrosive glue. And I put some hot glue on here. You don't ever have to worry about that, becoming corrosive or conductive. But yeah, transformers like this, it's a good idea to rebond. Stuff like electrolytic capacitors, I never worry about re-gluing them back down. They're not going anywhere. They've got really heavy leads on them. But these toroidal transformers have really thin wires. And literally just shipping a radio back to somebody, that thing could bounce around in there and break off those little tiny wires. So it's always a good idea to just put a little dot of hot glue on stuff like that to hold it in place. Just keep it from moving around. Re-enabled the AMC and ALC circuits because they had both been completely undone. Transistors pulled, diodes pulled, actually. Several parts, I'm not sure why they were pulled. They could have just pulled one part and it would have disabled the circuit, but they pulled other ones. So, yeah, neither here nor there. All of that has been re-enabled now. Another thing broke off. This trimmer potentiometer, actually a few more things broke off. This trimmer potentiometer here that's supposed to be down on the circuit board, as I had mentioned, he has that hooked up to this external little switch box here for a low power position. So when you flip the switch in one direction, it's low power. Flip it in the other direction, it's normal 4-watt carrier. Where in the heck is it? A little parts thingy here. And it was a good quality one, however in the heck you pronounce it. I never remember what is it. Piher fire or something like that. But yeah, it just. They were kind of corroded. It looked like this was probably used to start with, and I just couldn't get any. I'm not going to sit here and tinker around with a 25-cent trimmer potentiometer. So I just stuck a good new CTS in. Other thing that broke off while cleaning the glue here, I didn't even notice it. I got done with the radio, recapped, cleaned all the goop off of the bottom of the board. Got the radio flipped back over, hooked it up, turned it on, was receiving, went to transmit, and no transmit power. and it was transmitting before. It was not having output power problems before. So in the process of removing the glue, there was actually some glue up on this transistor right here, and this is your pre-driver. The camera back here. So this is your pre-driver, your driver, and then your final. The one lead on that was like hair thin, and it just snapped off. So put a new driver or pre-driver transistor in it. All three of these transistors mounted to this heatsink here. This one, the screw, I hadn't actually noticed, and I'd have to go back and look at the video previously, the section I shot previously, to see. It's probably visible in earlier sections of this video. The screw head was like that far out away from the transistor, and there was no insulating washer. You can see that one now has a ceramic insulating washer on there. There was nothing there. It was just kind of floating there. Yeah, I guess with the hope that some heat would get transferred into this. So, and these two had the wrong screws in them. This one was too big. Yeah, I've installed, actually all three of those screws were replaced with proper screws. I put nuts on the back of them, because that's another problem is, and it's a common problem, you can only take those screws in and out so many times in these radios. What you usually end up doing is stripping the threads, because they just thread into this aluminum plate, and aluminum's an extremely soft metal. So don't be surprised if you ever take off transistors like this, that the threads strip out on you. Be ready to put a longer screw in and put a nut on the backside. Let's see, was there anything else up here other than just tying up the wires a little bit, cleaning it up a little bit more? Like I say, it was a good working radio before. It had definitely had some problems, splattering all over the the RF spectrum because all the limiters being removed and all that goofy power mod stuff. But yeah, now that all that's been put back to original factory, it now does a good 4-watt carrier, 100% modulation, and 12 watts on sideband with no distortion. Good, looks really good on a double tone test. So that's the top side here. So actually, let me just get her turned off here. Gotta watch the little switch box back there. So, and there's the underside. So yeah, there had been a lot of work. I'm not sure if this thing might have had other modifications over the years, but yeah, there's been a lot of work in this PLL area, just actually all over the place. I'm not even sure what the heck was done to this. Parts, a lot of electrolytic capacitors looked like both of the leads had been resoldered, but the capacitors were original. They've never been replaced. Now, all the limiter transistors removed, that's, yeah, I knew that I was going to have to replace those, but yeah, there's a lot of other parts in here. I'm not sure if it was just experimenting, trying to figure out if, we take this part out, put it back in, do I gain anything? I'm not sure why, but yeah, there's actually a lot of damaged circuit traces in this radio. I mean, like the audio amp back here, there's a bunch of the circuit traces are just snapped off and missing, so, the leads are just laying out farther onto the trace, and, the solder mask was scratched off so they'd make contact, but yeah, it's like that all over, especially in the audio circuit, man. There's damaged circuit traces all over the place. Like I say, there was a lot of cold solder joints too. I honestly don't know how this thing was working, because I found some cold solder joints, and they weren't just work that's been done to it. Some of them were factory original solder joints. It's usually very easy to tell a factory solder joint from one that's been worked on. But yeah, some of the factory solder joints, the leads were just broken loose. So, they were just making contact by touching. There wasn't actually any solder, a solid solder connection anymore. I did remove the one modification that actually was on the switchboard here. Well, actually, there's two modifications. There's a resistor that's been removed right here. This modification was already here before. That's actually part of the clarifier modification. There's a resistor that would normally go on the underside here, or the top side if the radio is sitting upright. And that resistor is in series with the voltage source for, I guess that would be in receive. Yeah, in receive, that would be the voltage source for the clarifier in receive. And it's been hooked up now to be a continuous supply voltage source. And of course you want that voltage at a higher voltage, so that, I guess when he did this modifier, whoever did that modification, just took the resistor out and put a piece of wire in there. But there was a piece of, well actually it's right here, speaker wire went up to this board to the A and L switch. And that wire came back over here to, remember that trimmer that's kind of floating in midair on the top side here? The A and L switch was also hooked up to that, and it looks like that was meant to be a high power switch. I thought there was maybe a channel another channel modification button used up here, but actually it's just these 5 switches here. So all 5 of these are channel modification switches. Actually, these 4 are channel mod. Well, I mean, they're all channel mod, but these are your normal channel mod switches, and this one's a 10 kc switch. Like I say, that's the power switch. But that's the thing. They were actually using the A and L switch as a high power, so the high power would completely bypass it. The thing is, they didn't disable, or they didn't disconnect the wiring for the A and L and connect it together. So the A and L switch was still hooked up. Now, it's only 2 wires on the A and L switch, and this is a double pole, double throw switch here. So they just use the other set of contacts for that high power modification. Well, when you push the A and L switch for high power, well then the A and L's turned on. So you had 2 choices: no A and L, lower power, or normal power, or A and L turned on and higher power. Of course, we don't want higher power. Higher power is bad for radios. Remember all that crap that's been done over here? The driver and final have been replaced. It's what causes stuff like that, running radios at too high output power. So that was just removed. So now the switch operates exactly what it's supposed to be. You push the switch in, it's an A and L switch. And speaking of higher power, the power supply, there's a variable resistor on the power supply board that is to adjust the power supply output voltage. It was set maximum clockwise rotation, so it was at like 15.8 volts. Again, you're going to get a little bit more power. Honestly, it ain't going to make a difference on air. You're just going to end up, if nothing else, distorting, and more detrimental is, again, you end up burning up stuff like your driver and final transistors. You can supply, not only that, light bulbs, people that do that frequently find that light bulbs for meter illumination and indicators and whatnot, they just don't seem to last very long. Well, that's because they're 12-volt light bulbs. They're running normally at 13.8 volts, and then you go cranking up your power supply to like 15.8, so yeah, light bulbs tend to be short-lived, and actually a lot of parts, voltage regulators, you can have all kinds of problems, so that's been set to exactly 13.8 volts like it should be. So yeah, and there's a lot of melty wire down here. Yeah, when the soldering work was done on this thing, we apparently didn't take much care as to try not to melt all these other wires. So, and what I mean there is, like this wire right here, it's got a melt spots all over here. There's melt spots. Let me just hold on a second here. How well it shows up. You can see there's just melt spots all over this wire. It's a little charred there. You can't see any actual wire. That black spot's actually just a little bit of carbon. It's a little bit crunchy. But anywhere where wire insulation was burned through, like on the top side on a few spots, I actually desoldered the wires, put a piece of heat shrink tubing over them. But yeah, none of these are down to the bare wire. But yeah, these ground wires back here, anywhere where there was work done on this radio, yeah, you can tell somebody came in with a soldering iron and laid their soldering iron. It just burned. All of these wires have melt spots. All along here it's melted. All in here it's all melted. This ground wire is just all melted. This green wire, you can see that thing, how, gunked up it looks. Like I say, melt spots all over the place there. So, yeah, when you're working on radios like this that have a lot of wiring, it sucks that they do that, but they do. It's just the way the radios are designed. There's lots of wires. Try to be careful when you're coming in with your soldering iron. I mean, I find, don't get me wrong, I accidentally do that every once in a while. I will touch a wire with the side of the soldering iron and don't intend to. It happens. You're looking at the component, you're trying to bring in your soldering iron, bring in a piece of solder, sometimes trying to hold a component lead with your fingernail while you're bringing the solder in, and you're not looking right here, and you don't notice that your wires, you don't notice it until you start to smell funny smelling smoke, not normal flux fumes. But yeah, just absolutely no attention was paid to that in this thing from the looks of it. So yeah, just be careful when you do stuff like, I mean, like I say, all of these, almost every single wire in this thing's got scorch marks on it where it was melted. Like I say, luckily it's not like the iron was just laid on it and left on it a long time. So, they're not burned. None of these down here were burned through, but yeah, it's just a word of caution when you're doing stuff like this. So, I guess about the only thing I really have to do to this now is just last little bit of cleanup. I've already cleaned the flux residue off of the circuit board. I guess you could probably tell that it's a Uniden, and you could actually see green. It wasn't brown, because Uniden tends to leave a lot. They never cleaned off the flux residue very well on the 858 chassis. They're usually rather brown. But just a last little bit of cleaning up. Basically get the cover on it and clean the faceplate and the knobs up. Got to pull the knobs off and clean all that up, and it'll be good to go again. So there's another one ready to get put back into service. Good radio. Yeah, the channel mod, it is what it is. I am gonna tidy this up some. I'll put a piece of this split wire loom over top of this to try and tidy this up a little bit. I'll kind of wrap it up like this, and then put a piece of split loom over top of it just to neaten the installation up a little bit. I did put some glue here as well. There wasn't anything here, so I put some glue on here just for fear. You never know. Radios get moved around. If the wires get moved a lot, there's sharp edges on that metal there. So I put some glue around the wires on the inside, so it's not really noticeable from the outside, but the inside, they're actually glued to the inside of the chassis, so they can't move around. They won't get rubbed through and short out, because, of course, most of these wires are going to have voltage on them because they're channel modifications. So, that's all that's doing is supplying voltages to different pins on the PLL. So, yeah, we definitely don't want any of those shorting out. So, just a little bit of glue fixed that up. So, there you go. There's a realistic Navajo TRC-457. Like I say, about the only thing I have left to do now is a little bit of cleanup. It's in really nice condition, actually. That's why it's got tape on it, because the bezel's really nice. Just a little bit of dust on the knobs, a little bit of finger goo, but that'll clean off really easily, and this should be a really nice looking radio. Like I say, it is nice that when the channel modification was done to it, no holes were drilled. Just use this hole right here, the top cover mounting screw, to mount that box. So, if at some point in time somebody wants to remove all those channel modifications, it's just a matter of pull all those wires out of that socket there, desolder a few other ones, pull the wires out, throw the box and whatnot in your recycle bin for electronic recycling, and you've got a factory radio again with no holes and nothing to rewire. It's just a matter of removing that stuff. So, there you go.